Toxicology. The science of toxicology, or the science of poisons, is the study of the harmful effects of chemicals on living organisms. Scientists who study these harmful effects and assess the probability of their occurrence are called toxicologists. Toxicology encompasses the study of the adverse effects of chemicals on living organisms. Toxicology assesses the probability of hazards caused by such effects. Toxicology estimates the results of these effects on animal and human populations. Toxicology studies consider the cause, circumstances, effects, and limits of safety of unintended harmful effects of food, food additives, drugs, household and industrial products or wastes. Toxicological studies deal with adverse effects ranging from acute to long-term. The important science of toxicology has direct relevance to human health, the environment, and major sectors of the economy. The scientific community, governments, industry, and the public all require information on the effects of potentially hazardous substances to balance the benefits which society receives against the hazards that may occur from their use or misuse. So what does all this mean to workers who are not toxicologists? It serves a great purpose for everyone to be familiar with things that can harm them and basic safety policies and procedures to reduce exposure to potential risks. Education and knowledge are two primary considerations in helping reduce your exposure to harmful chemicals and other similar products. You have all seen chemical labels, material safety data sheets, and other signs and labels. But have you fully understood the information presented? The answer is probably no. This information is highly technical, and unless you work in this particular field, it is understandable that you would not know the answer. So what we are trying to do in this particular program is to provide some basic information relating to industrial toxicology. So when you come across chemical information, you will have a greater understanding of these labels and chemical information. First, let's take a look at toxicity. Toxicity means the amount of toxin or poison, which under specific conditions will result in detrimental or bad changes in your body. Toxins cause injury in relatively small amounts compared to other substances. Toxic materials may be classified as toxic in very minor amounts or in larger amounts. In other words, some chemicals may have only small amounts of toxic material, but they can be very hazardous. It all depends on the toxic concentration in the chemicals. Concentration is the quantity of a substance that is exposed externally to a biological system. Exposed externally can mean in the air, vapor, gas, or other similar area, which can be absorbed by a human. This absorption can be through breathing, the skin, or other entry. There is another term called dose. Dose is the quantity of a substance that enters into the biological system. Dose is not the same as concentration. Dose is basically how much of a substance actually enters your body, whereas concentration just means how much of a toxic substance that is exposed externally to a biological system. Quite often you'll see ppm, or parts per million of something. It is a means of stating a measurement of the toxicity of a particular chemical. There are several factors to remember, but we'll just explain the basics to give you an idea of what a parts per million or parts per billion really means. 10 parts per million is nothing more than 10 parts of something within a million something space. Let's take a bottle filled with 1 million parts of air. Drop in a substance of 10 parts of chemical, gas, vapor, or something. Now you have 10 parts of something per million parts of air by volume in that bottle. That information is not of value except to tell you 10 parts of something is in the bottle of a million parts of air. So you know by reading the label that this container of air contains 10 parts of something. Is that harmful? Actually, it depends on the toxicity of the substance. If you put 10 parts of nitrogen, which is basically harmless, into a container of a million parts of air, then the entire bottle of air is harmless. If you drop 10 parts of cyanide gas, you would have a mixture in the bottle of 10 parts of cyanide per million parts of air. Is that mixture harmful? You would have to go to chemical tables, regulations, or material safety data sheets to determine if 10 parts per million of cyanide gas is harmful. Some chemicals are harmful or deadly at 1 part per million. The lesson to be learned here is to read the information that is available to you about chemical mixtures, and then find out if this mixture is harmful. 10 parts per million doesn't tell you anything except that there is a substance of 10 parts of something in a million parts of something else. Each chemical is different, with different concentrations of hazards. Identifying by parts per million or parts per billion is just one method of identifying potential health hazards. There is more information you should know. Acute toxicity and chronic toxicity. Acute toxicity is the toxicity resulting from exposure to relatively high concentrations of a toxic material over a relatively short period of time, such as seconds, minutes, or hours. Acute means quick, so you don't have to be exposed to this type of chemical for any great length of time for it to be harmful. Chronic toxicity is the toxicity resulting from exposure to a relatively low concentration of a toxic material over a long period of time. This time could be days, weeks, months, or even years. Chronic toxicity could take several months or even years to feel the effects of exposure. With acute toxicity, you would feel the effects almost immediately. Which one is the most harmful? Actually, the answer depends on the concentration, exposure, and so on. But if you experience acute toxicity, you know it almost immediately and can seek medical attention. Chronic toxicity is somewhat more devious because you may not know about the toxins poisoning your body for years. As an example, if you work around fumes and vapors of the chemicals used in a paint, after a short period of time you may no longer be able to smell the fumes. You can get used to the smell, or your smell can be desensitized so you don't notice it. Over a period of time you are not noticing the smell, so you think everything is okay. However, some of these chemicals are getting into your body and slowly destroying your liver, your kidneys, and other vital organs. You may feel fine for a long period of time, and then one day you may begin to feel ill because these toxic chemicals are destroying one part of your body. So in some cases you could say that chronic toxicity is more hazardous or dangerous than acute toxicity. However, you have to keep in mind that some acute toxicity can kill you immediately. Both are bad. So prevention of chemical exposure is of primary importance. IDLH, or immediate danger to life or health. IDLH is defined as a situation that poses a threat of exposure to airborne contaminants when that exposure is likely to cause death or immediate or delayed permanent adverse health effects or prevent escape from such an environment. It is also stated that the purpose of establishing an IDLH is to ensure that the worker can escape from a given contaminated environment in the event of failure of the respiratory protection equipment. Immediate danger to life or health can be serious situations, of course. Naturally, you would enter such an area at great risk only with proper and appropriate personal protective equipment. These areas are generally known and identified, and people who must enter these areas are specially trained and know what protection is required. The information you should know as a basic introduction to toxicology is that there are such areas which are very dangerous, and you must always know what you are doing to enter these areas. You must have special training, special knowledge about the equipment you're using and what to do in case of an emergency. We mention it here in passing because of the requirement for special training and equipment. But you should understand what an IDLH is and to stay away from any area so designated or one that has the potential for an IDLH situation. One simple example of an IDLH could be working on a sewer. Sewers generally emit a toxic gas or vapor called hydrogen sulfide, and the smell is something like rotten eggs. There have been numerous people killed in sewers because people entered them without proper respiratory protection, or they were trying to save someone who had been overcome by the gas. Without first testing the atmosphere in sewers or other potentially hazardous confined spaces, you don't know whether the air is safe or unsafe. All sewers and many confined spaces can be in IDLH, and the only way to know for sure is to test the air before you enter one of these potentially hazardous areas. So far, we've touched on some very basic information. But the most important thing to learn here is that you need to know and understand chemical terminology when you're working with, around, or near chemicals and hazardous materials. Don't take any information for granted. Make sure you understand the information provided to you. Read the information on chemical labels and material safety data sheets for the chemicals you're using. If you have questions, have your supervisor explain or provide proper information about the chemicals, what personal protective equipment is required, and how to properly use the personal protective equipment if it is to be used. Don't forget to know about flammable liquids, flash points, combustibles, upper explosive limits, lower explosive limits, and other information. Take the time to follow up on this short introduction to toxicology by looking more closely at chemical and hazardous material information, labels, and those material safety data sheets. Learn the hazards, then apply the prevention required to reduce or eliminate the hazards. That's what safety is all about, preventing accidents, injuries, and illnesses before they harm you. Your best prevention technique is through knowledge and understanding information. Thank you.